Okay, what we're going to be doing today, we're looking at solving simple equations, just a one-step equation. But the theme throughout the teaching is going to be the steps that you need to do, the things you need to ask yourself in order to get the right answer all the time. And on a problem like this, you're going to know the answer already, but we are learning how to do the step-by-step process in order to solve an equation. And the first thing that I'd really like to do is to make sure that you're using the lines of your paper. It's going to be very important to do that. So first we're going to copy the problem, and we have x minus 8 equals 9. Now most of you are already going to know what the answer is, which is fine, but we're not just trying to get the correct answer. We're trying to learn a process, and we're trying to learn how to then check our work by substituting the value of a variable. So here we have a simple equation, x minus 8 equals 9. The first thing that you should really be doing, go ahead and set up a junk column so that you would be able to do any work necessary outside of junking up your equation. Then we're going to go ahead and we're going to draw a line vertical through the equal sign so that we in fact know that we've got the left side to an equation. We do have the left side and we have the right side. And this is going to be beneficial later when we start talking about equations that have more length to them. The next thing that we're going to do is isolate our variable. I'm going ahead and I'm going to box it out. So I know I need the x all by itself. This next part is the most important. It's just the critical thinking where you're saying to yourself, I want the answer to that x. I need to know the answer. And what is in the way of the variable being by itself? If you look, it is a subtracted 8. If you looked at it all by itself, it might look like a negative 8. Either way, you have to say, I need to get rid of that subtracted 8 for my variable to be by itself. Then you ask yourself, what is going on with that term? Well, it's subtracted. Then ask yourself, what is the opposite of subtraction? What is the inverse to subtraction? What undoes subtraction? What is the opposite of a negative 8? And we would find that we would be adding 8. Notice I put the 8 right under the term that I'm eliminating. It would not be wrong for me to move it over under the x, but just to organize your thoughts, keep it under the term that you are eliminating. And it's very important before you do anything else to say whatever I do to one side, I'm doing to the other. Once we get that far, we're going to say, okay, I'm done with my thought for right now. I need to draw a line on the left side and on the right side because I want to calculate everything I've done so far. And by design, you can look and you've got, whether you call it a subtracted 8 with an added 8, a negative 8 and its opposite, a positive 8, the total would be 0. You have eliminated that term. Then I always tell the students, draw an arrow down because what you do have left is the x by itself, which is exactly what you wanted. And then you have 9 plus 8, which is going to give you 17. Now, we, of course, know that that is the correct answer. However, I want to make sure that the students, get rid of this, I want to make sure the students are going to check their work. And so by checking their work, they would rewrite the problem, and I'm going to actually have them write the word check. They want to check the work. They should do this to not only see that they have the right answer, but to learn how to substitute the value of a variable in an equation. So we copy the original equation, which is x minus 8 equals 9. By substituting our value, our 17, in for x, we would rewrite it as 17 minus 8 equals 9. And then we can look again and say 17 minus 8 equals 9. Does 9 actually equal 9? Well, the answer to that is yes. And so we know we have a correct answer. Now, we're going to look at a couple others where we would look at a problem. Wow, happy face, let's see. We would take a look at the same type of thing, and the only difference with this problem is they gave us a subtracted 2.2, a decimal. We would just have to know that we would be adding a 2.2 to both sides. On a problem like this, a little bit more intense, where they are looking at a fraction. Well, I'm going to go ahead and copy this down where we have u plus 2/3 is going to equal 7 1/2. Again, draw the line to calculate. We should have a left side and a right side. We should have a junk column. We should be able to isolate our variable. And then again, ask yourself, what's in the way? Well, it's an added 2/3. What is the inverse, the opposite of 2/3? And it would be taking away 2/3. Whatever I do to one side, I should make sure that I am doing to the other. And again, we say, I'm done with this part. I'm going to calculate everything. On the left side, we would look at our number, 2/3, and the opposite, which would give 0. We bring down our u. Now, the only catch to this is, now we look, and what do we have on the right side? This is where we're going to take a look, and we say we've got 7 1/2, and we need to take away 2/3. Using our skills, we should recognize that what we actually need to do at this point is we would need to get a common denominator for 2 and 3 and an equivalent fraction. Students should be able to do this in their junk column. So we have 1/2 and we've got 2/3, and the least common multiple or the least common denominator would be 6. Since we're going to have 6 as our common denominator, we need to go ahead and say, what do I need to multiply 1/2 by in order to get to 6? 2 times 3 would give us 6, so we would be multiplying by 3/3, which equals 1. The identity property of multiplication tells me I can multiply any number by 1. The value stays the same. The numbers might look different. So we have 3/6. Here would we be multiplying by 2/2. 3 times 2 is 6. 2 times 2 is 4. And so we end up on this side as 7 3/6, and we are subtracting 4/6. Here's where some students may want to borrow, or some students may want to turn these into an improper fraction. 7 times 6 would give me 42, 42 and 3. We'd have 45/6. We are subtracting then 4/6. And if we take a look, that would be like saying 45 minus 4 all over 6. And we would get, which is going to give us a difference of 41/6. And if we want to turn that improper fraction into a mixed number, we'd say 6 times what gets us to 41? And we would end up with 6, which would be 36. And we would have 5 left over and keep the denominator. So we would either have 41/6 or 6 5/6 would be your answer. That's it.